So, hello everyone. Today we are going to solve the question on CodeForces. So, we are solving the BitMasks questions, and today we are going to solve the question number 5. Okay. So, let's see what is the question. Question it says we need the zero. Okay. So, there is an array containing of non-negative integer. You can choose an integer x, denote bi is equals to ai XOR x for all I, okay, where this is XOR operation, and it is possible to choose such number x that the value of the expression b1 b2 b1 XOR b2 XOR bn equals to 0. Okay, so basically it says we have given an array. Okay, so let's open whiteboard. Hmm. It says we have given an array, right? So let's consider the example of this. We have 1 to 5. Let's say 1, 2, and 5, right? These are three numbers we have. So it says find the x such that such that, and there is a relation given that is bi is equals to ai XOR sorry, okay, ai XOR x, right? So this is the relation, means we have to find a such x. For that, when we take the XOR with the all the elements of the array, then then after that we will take the again XOR with all the results. Then after that we will get 0. Means it is said that B1 XOR, actually there are three elements here. So B1 XOR means B2 XOR and B3 XOR. It should be 0. Okay. So if we break out B1, so B1 is nothing but A1 XOR X, right? And again XOR, and B2 is nothing but B2 is nothing but A2 XOR X, right? And B3 is nothing but A3 XOR X. Okay, okay. This is basically XOR. Yeah. So in this situation, our result should be 0. We have to find such X. We have to find such X. For that, this should be 0. Okay. So can you think below the property of XOR, if we have something y and we take the XOR with itself, means y, then it will be 0. We know the property of this. And if it is not same, then it will be 1. Right? So here we can see this is the odd number of n is odd. Basically, there are three number in the array, right? Three elements in the array. So uh, here we can absorb something. Here yeah. So here you can say when the whole result will 0, right? So there is a possibility when we take if we XOR x, this x will perform by XOR with this x, it will be 0. Then we have something remaining x, right? And we have a rest of thing a1 XOR a2 XOR a3 and XOR x. Here we have only three elements. If we have n elements, then it's like a1 XOR a2 XOR a3 XOR dot 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 an and XOR x, right? Okay, so we have to think here something. uh, yeah. So uh, what we can say here, if we take, yeah, So when this result will 0, when this part is same something, let's say y, and this is XOR x. So if this and this should same, then we can say it will be 0, right? So we get a condition if A1 XOR A2 XOR A3 is basically whatever the value of A1 XOR A2 XOR A3 will be our answer, because we need something x, for that it whole result will 0. So if suppose if we put if we, let's say, drop this, and when this our whole result will 0, when suppose if I put A1 XOR A2 XOR A3, right? And instead of x, if we put something like again A1 XOR A2 XOR A3, then the whole result, because A1 is matched with A1, so it will be 0. A2 matched with A2, it will be 0, and A3 matched with A3, it will be 0. And in this situation, our result will 0. So here we got a point. When our n value is odd, then answer will be what? A1 XOR A2 XOR A3 XOR dot 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 AN. This is for odd, right? And if we talk about the even, so let's see if we take the example of even. So just rub it. Okay, so let's take another example. Let's take something like 1 2 2 3. 1 2 2 and 3. Here there are four elements, right? So hmm, so basically what will happen here, if we directly write something like let's say A1, I am denoting plus as a XOR, right? So let's say A1 XOR A2 XOR A3 XOR A4, right? And let's say it's B1 B2 B B3 and B4. We have to find this, and this should be 0. And when we put the value of B1, so B1 is nothing but A1 XOR X, right? Plus B2 is nothing but A2 XOR X, right? A3 is nothing, B3 is nothing but A3 XOR X, and what is the last one is basically B4. So B4 is nothing but A4 XOR X. So here basically n is even, so we get the x in pair always, x always in pair. So these x will be 0 after XOR, right? Then at last we get A1 XOR A2 XOR A3 XOR A4. So when this result should 0, when whole result will 0, obviously. So here we got the point, one more point. If our n is even, then our answer should be, our x should be what? 0, obviously, because x is eliminating automatically. X will be anything. X can be anything, because x is eliminating all the time, because n is even, then x is always appear in pairs, so it will be eliminated. Rest of the things we have only A1 A2 A3 and so on. So we can say that in this situation our answer should be 0. We can say anything, but here this is saying that -1. How? Let's analyze first. 1, 2, 2, 2, 3. So basically it says, okay. For each cases, parent x, and if there is exist, if it is exist or -1 otherwise. Okay, and one more thing. Hmm. So when we have number even, so x will be automatically eliminated. Mhm. And if XOR of all these things is 0, means for any value of x it will be 0. But here it says x is lies between from 0 to 2 raised to the power 8 only. So in this situation we will see no, because if whole XOR value is not 0, then we can say yeah. So if we see, let's say, if we performing the XOR of this, so 1 is 1 and 2 is 1 0, so it will be different 1 1, and again we will take 1 0, so different on different weight it will give 1, same it will give 0, and when we put 3 itself it will something like that, so it will be 0, and it will be something like 1, right? So that means this is not giving us 0. Okay, yes, this is not giving us 0, that's why it is its answer is 1. So if we have n is even, then we will take the XOR of all elements a1 XOR a2 a3 a4 an, and if the whole result XOR, if we perform the XOR operation with all the elements of this, and if whole result is 0, then it is okay. Yes, then we can say okay it is exist, but otherwise we cannot, we will print -1. Okay, so let's another example with 4 digits. This is 0 1 2 3, right? So when we have 0 0 1 2 3 0 1 2 and 3, right? So we know all the XOR x are cancelled. Okay, so we have something like when we perform the XOR operation on this, so what will happen, this is 0 and we perform 1, so 1 is this, so different bit is 1. Now we have 2, so 2 is this, and here different bit, so we get 1 1, right? And we have now 3, so here we get 0 and 0, so here result will be 0. That means uh, we can say x value is anything whatever you want to say, between 0 and 2 raised to the power 8 you can give any value, right? So this is the intuition. So let's solve and see. So what we will do here, uh, we are going to take input first. So what is the input here? Basically we have to take array, right? So here test cases there as well. So while, right? So here first we will take the input n, and then we are going to take we have to create an array. So in array of n size, and we take the input all the elements of the array, and this is nothing but n, and we will say c in. Okay, so instead of this, what we will do, we will create just an empty set with n size, right? Yeah, this is done. Okay, so here we have taken the inputs, right? So now next thing is, now what we have two observation. If our n is even, right? So we have to check if our n is even, means n modulo 2 is equals to 0. Then in this situation, what will happen if we take the XOR of all the um, you can say XOR of all the elements, then if result of result is 0, then we can say yeah, it is possible. So we will print any value, any value. So what we will do here, we will say int, let's say XOR, and what is the constraints basically, it is okay. So int XOR is equals to 0, and we traverse the whole loop, a whole array basically, and we will start from 0 and we will go to the end, and we will say x is equals to x XOR a of I, and at the end we will check if, because in this situation all x are eliminated by themselves, right? Because n is even, so x is always occurs in pair, so they will cancel themselves. So next thing is, now we have calculated all the XORs. So we check if x is not is equals to 0, in this case we will see out -1, right? We will print -1, right? Else, in else part, you can print 0 or anything, whatever you want, because x is lies between 0 to 2 raised to the power 8. Okay, so there is no restriction here. Okay, so here in this case we will print 0. Yeah, is, if suppose n is odd, so in this situation what we will do, uh, what we have seen earlier, if n is odd, so n is odd means uh, yeah, n is odd means when n is odd, then we get 1x and all the a1 a2 a3 an, so answer will be all the basically XORs. Yeah. So what they will do, instead of taking XOR of all the elements inside this, we can take it outside. So it will be, so we can use it in both the condition. Right. So now we can use. So here we have, now we will check this, and if this is, then, and otherwise if n is odd in this situation, our answer is basically x itself. Right? So just take the test case and see it's working or not. And it's let's see. So you can see here in the first test case there are three elements. So we got six. Okay, odd is there. In the next one we have again three elements, and when we take the XOR of this it will be 0. Okay, so it will be 0. Odd is okay. Now we got the even number. So in this situation we can print anything whatever we want, because answer always win. If you talk about the even. Yeah, so and the last one is you can say -1, it is okay, and then 1. Okay, so let's submit it and see it's working or not. But one more thing we have to see here, in this situation why it is giving 3. We have something like even, so it will be okay, it is okay. But when it is okay and in this situation it is giving 3, let's see, let's see and see it's what it is saying. We need the zeros, 0, 0, 0, 0, 0. So it's running and yeah, it's accepted. So I think you got the intuition how we can solve it. Because if you talk about this case. So in this situation, x will be anything, but he's restricted that the x should lies between always 0 and 2 raised to the power 8. So we can uh, we can always say 0. Why we are going to take any number? Yeah. So this is the solution. I think it makes sense. So